Hello students, this is Professor Chalai, and in this video we're going to look at percent yield. By the end of this video, you should be able to calculate the percent yield from various experimental results. As always, you can follow along with our Chapter 4 workbook. Now, in our previous video, we talked about how to identify limiting reagents and how to calculate theoretical yield. And just as a refresher, the limiting reagent is a reagent that gets used up first, or in other words, it's a reagent that produces the smaller amount of product. That smaller amount of product that's produced from the reaction is the theoretical yield. However, in real life experimental settings, you will almost never get your entirely calculated theoretical yield from an experiment for various number of reasons. Something might go wrong, you lost a little chemical somewhere, maybe not all of the molecules react, things like that. So what you would obtain after you actually perform the experiment is called the experimental yield. So the experimental yield is the amount of product obtained from an experiment. And typically this will be smaller than the theoretical yield that you calculated before for the reasons that I mentioned. And so our percent yield is simply how much you actually got from the experiment versus what you calculated in your limiting reagent calculation. So from the calculations. So the actual yield, which is going to be usually smaller than the theoretical yield because something probably didn't go entirely correct, times 100% is the percent yield. With that, I would like you to try numbers 27 and 28 by yourself first before I go them over again, because I think you have all the tools that you need to answer this question. So pause the video, try to work it out on your own, and then unpause, and I'll go over these questions for you. Okay, so let's look at number 27. In number 27, we have a reaction where we started with 1.274 grams of copper sulfate and excess zinc, and we produced 0.392 grams of copper metal. So copper metal here is our product, and copper sulfate is our reactant that we started with. It's our limiting reactant. Why is it our limiting reactant? Because they already tell us that we have excess zinc. So zinc is going to be in excess, so we don't need to do a limiting reagent calculation. We already know that copper sulfate is our limiting reagent. But we still need to calculate our theoretical yield, because this here is our actual yield. This is what we actually obtain according to the from our experiment. So we need to figure out what the theoretical yield is first. So let's do that. So theoretical yield, and it's our theoretical yield of copper, because copper is the product that we're interested in. So let's do that. So we're going to start with 1.274 grams of copper sulfate. And the first step in any of these calculations, you typically convert to number of moles. So we just need to divide by number of the molar mass of copper sulfate, which I've already calculated, and calculated to be 159.61 grams of copper sulfate per mole of copper sulfate. So that cancels out nicely. Now that we have moles of copper sulfate, we can convert that to moles of copper using mole ratios. So according to this equation, 1 mole of copper sulfate will produce 1 mole of copper. So we just have 1 mole copper sulfate for 1 mole of copper. And now that we have the moles of copper, to actually get the theoretical yield in grams, we need to convert to the mass using the molar mass of copper. And the molar mass of copper is 63.55 grams of copper per moles of copper. You plug those into your calculators and you will get 0.5072 grams of copper. So I'm just going to circle that. This becomes our theoretical yield. Now that we have our theoretical yield and our actual yield, we can go ahead and calculate our percent yield. So our percent yield is just going to be our actual yield, which we got from the experiment, 0.392 grams, divided by our theoretical yield, 0.5072 grams times 100%. Plug all of these into your calculator, and we get 77.3%, 3 significant figures, so 3 significant figures. And there it is, that's our percent yield. I hope you all got the correct answer. If not, you can let me know what you got, and we can work it out together. But now that you've done that example as well, if you haven't yet done so, try number 28, pause the video, and then when you unpause, I'll go over it for you. Okay, so let's look at number 28. It's asking for the percent yield that produces 12.5 grams of Freon. So this is our actual yield in the experiment. And we started with 32.9 grams of carbon tetrachloride. And we have excess hydrofluoric acid, so we know that's excess. So if we have our limiting reagent, let's figure out our theoretical yield. Theoretical yield. Our starting amount, it says, was 32.9 grams of carbon tetrachloride, so 32.9 grams. Oops, it's 32.9. There we go. 32.9 grams of carbon tetrachloride. We need to divide by the molar mass of carbon tetrachloride to convert to mass, and the molar mass of carbon tetrachloride I found to be 153.82 grams of carbon tetrachloride per moles of carbon tetrachloride. Now that we have moles of carbon tetrachloride, we can find moles of Freon, which is our interesting product, the product that we're interested in. So 1 mole of CCl4, according to this equation, goes to give us 1 mole of CF2Cl2. Okay, now that we have moles of Freon, we can convert to mass of Freon to get our theoretical yield. The molar mass of Freon is 120.91 grams of CF2Cl2 per mole of CF2Cl2. So you plug all of this into your calculator and you get 25.9 grams of CF2Cl2. I'll circle this for now. Okay, so now that we have the actual yield and the theoretical yield, we can calculate our percent yield. So let's do that. So our percent yield would be equal to our actual yield, what we got from the experiment, which according to this was 12.5 grams. So here we go. 12.5 grams. The theoretical yield that we just calculated was 25.9 grams. So all of that times 100% gives us a percent yield of 48.3%. So there we have it. There we have our percent yield. We need to make sure that we have both the theoretical yield and the actual yield. In both of these examples, they give us the actual yield from the experiment, and we needed to calculate the theoretical yield, and then we use those two to calculate the percent yield. In some cases, you'll also have to figure out which one's the limiting reagent. In both of these problems, they already told you which reagent was excess, and so therefore which reagent was limiting. So we didn't have to figure out which one was limiting. So we did, so it was a little bit quicker to perform. All right, that will bring us to the end of calculating percent yields. I will see you in our next video where I'll talk about quantitative chemical analysis. I'll see you then. Bye.